Let's talk about the different ways that we can describe relationships between variables. The first way to describe the relationship is that they can be either linear or nonlinear, or curvilinear. Linear relationships are when the relationship between the two variables can best be represented by a straight line. As one's height goes up, the shoe size goes up. As the number of cookies that Beep Beep eats goes up, the number of cans of Coke that he drinks before bed goes the other direction. So that's a linear relationship. Now, sometimes relationships can be represented best by a curve. And for example, if we were to measure porridge temperature and satisfaction. So if we have porridge that's very cold, that's not very satisfying, low satisfaction. If we have porridge that's very hot, that's not very good either. It'll burn the roof of your mouth. That's not very good. But there's not a straight line between them, because if we have porridge that's just right, we get a curved relationship that the porridge that is just right tastes a lot better. It's a lot more satisfying than the porridge that's too hot or too cold. So since that relationship is best described by a curve, we call that a curvilinear relationship. Now in this course, doing stats with curvilinear relationships is much more complicated. We're just going to be concentrating on linear relationships. And in fact, we're going to assume that all of the relationships that we're looking at are linear, whether they are or not, generally assuming linearity, assuming a linear relationship is pretty good, and we'll get decent results. A second variable to pay attention to are negative and positive relationships. Positive relationships are that when one goes up, the other goes up too, and a negative relationship is that when one variable goes up, the other variable goes down. So for example, if we're looking at my friend Beep Beeps. I don't know if you've met Beep Beep. He's the bear that's behind me over there. He takes a nap every day, and when he tends to eat snacks before he goes to bed, and he's discovered that the more jelly beans he eats, the longer his nap is. So we would say that the relationship between jelly beans and nap time is a negative relationship. If he eats more jelly beans, he'll sleep longer, and if he eats fewer jelly beans, he'll sleep a shorter amount of time. So that's a positive relationship. As one goes up, the other goes up. As one goes down, the other goes down. Now, a negative relationship, that's when one variable goes up and the other goes down. And we saw that in the illustration of the cans of Coke and the cookies that he drank before going to bed. The more cans of Coke that he drank, the fewer cookies he ate, and the more cookies he ate, the fewer cans of Coke. So as one went up, the other went down, and that's the same thing as saying that as one goes down, the other goes up. So that's a negative relationship. Now you might recall from algebra that this sounds very much like slope. A positive slope means that as one variable goes up, both go up, and a negative slope means as one goes up, the other goes down. So it's the exact same idea. Another factor to be concerned about, to consider when we look at relationships between variables, there's perfect and imperfect relationships. Perfect relationships are like the relationship between the weight of fruit that you buy and the price. So when you buy 1.5 pounds of oranges and you put them on the scale to calculate the price, it's going to be an exact straight line for whatever quantity of oranges you have. Everything's going to be right on the line. But that's oranges in a supermarket. And when you deal with humans, when you deal with psychological variables, when you look at people's behavior in organizations, most of the points don't fall on a line. Because sometimes if you have a really nice boss, some people will increase their performance, other people will decrease their performance. Whatever variable that we change people are going to respond to differently, and that's going to impact the dependent variable that we're looking at. So in general, whenever we're measuring psychological variables, we're going to have an imperfect relationship. You can't predict anything perfectly, but you can have a general idea of what the trend is going to be so that you can predict what would happen in the long run on the average. And so all of the relationships that we're going to look at, we're going to assume that they're imperfect and not all of the points lay right on a line. Here's an example of an imperfect relationship. Let's see, I will move off to the side here. There's an imperfect relationship between TV watching and reading skill. And this is a negative imperfect relationship. So we have down here at the bottom, we've got the amount of television watched in hours per day, ranging from 0 to 8. And then we've got some kids' reading skills going from a 0 to 100 score. And in general, we can see that the kids that watch TV the least have the best reading skills, and those who watch TV the most have the worst reading skills. So this is a negative relationship. But we look at the trend line here, and not one dot actually lies on that line. So it's an imperfect relationship, and some of them are really unexpected. There's some kids that watch a lot of TV but do really well in reading. And there's other kids who don't watch too much TV, but they do really poorly. So the dots are kind of all over the place, and we say that this is an imperfect relationship, and specifically an imperfect negative relationship because it goes down as this variable, the x variable, goes higher. Now, when we actually talk about a correlation constant, when we get a number for what we're doing, what's this number going to mean? It's going to measure two things. First of all, the strength of the relationship, how strongly the two variables are tied to each other, and it's also going to measure the direction of the relationship, whether they go up together or as one goes up, the other goes down. And the strength of the relationship will always be between 0 and 1, where 0 means not at all related and 1 means perfectly related. And the direction will be either a plus or a minus. So there's always going to be two parts to the correlation constant. The most common correlation constant that we use is the Pearson correlation coefficient, and it's typically represented by R. And it varies from -1 to a perfect negative relationship to +1, a perfect positive relationship. There's other correlation coefficients, but conceptually they're pretty close to R. Let's look at what different R's look like. Here we have 4 positive relationships, and we'll start off with an R equals 1. With an R equals 1, we've got two variables here. We've got X, which is a score on a test, and then we've got Y, which is employee performance. And one of the things in organizational psychology that we're concerned about is trying to figure out the best employees for a job. And so if we can give them a test beforehand to find out how they perform, then we can hire the best people. Now here, with this test has a perfect relationship. If we know their test score, if they get 15, their performance level is going to be 12.5 exactly. If they got a test score of 20, it would be 15.5. Unfortunately, tests like this don't exist. They just don't. We can't guess people's job performances this effectively from a test, so we try to find better things. Occasionally, there might be a test that has or a series of tests that might give us a correlation of 0.75. And now with 0.75, we see that the dots are spread out pretty far along the line. Someone that has a test score of 12.5, their performance might go between about 8.5, which is below average, to about 13, which is above average. So, but they probably wouldn't be super low, and they might not be super high. That probably won't be super high either. So a correlation of 0.75 would still be a really good predictor of how well someone would do on a in a job. However, it's more likely that we'd get a correlation of something like 0.39. In fact, being able to predict a job performance with the correlation coefficient of 0.39 is still really good. That's better than what most personality tests can do, but sometimes job sampling tests, where you actually give somebody some of the actual work to do and see how well they do it, can come up with these types of scores. So here, once again, the scores are all over the place, but the trend line indicates that in general, as the scores get higher, we can expect people to do better than average, and as they get worse, we can expect them to be below average. Now, when R gets down to 0.23, the dots are all over the place, and we can barely tell that people with high scores will do better than people with low scores, but we've got evidence that they do more so than what we would expect by chance. So even with a correlation of 0.23, we could use this type of job predictor to help hire people. We wouldn't want this to be the only criteria that we would use. We'd want other things besides this test, but this could be we could add this into a bunch of different things that we're considering. Now here's some examples of R from APU undergrad samples. So if we were to look at just males, the correlation between height and shoe size is really high. It's 0.95. If we know the height of a male, we can pretty much guess their shoe size. Now we might be off a little bit because shoe sizes vary a little bit, and there's some people that sometimes they should wear right in between a 10.5 and 11, so sometimes we'll get a 10.5 and be a little too small, and 11 will be a little too big. Now, and it's interesting, if we mix males and females together, the correlation goes way down, and that's because the shoe size used by males and females is different. So a size 9 shoe for males is different than a size for female, so that introduces error into our measurements when we try to guess people's heights. Now the relationship between height and sex is also pretty strong. If we say that males are 1 and females are 2, the correlation is minus 0.75. And that means, in general, males are taller than females, but there's quite a few females that are taller than quite a few males, so it's not a perfect correlation. There's a commitment to Christ and anxiety. Now this is an interesting one because APU seeks to be a Christian university, but you don't have to be a Christian to come to APU, to Azusa Pacific. And but one of the things that Christianity teaches is that people that personally follow Christ should have a life that's transformed by him. And so I did a study where we looked at people's commitment to Christ, and it ranged all over the place from, I really don't care what the Bible says or what Jesus taught, to I'm willing to die for everything that Jesus wants me to do, to, oh, I think Jesus is a good guy, and I'd like to do more or less what he says. So we asked a number of questions to get a commitment to Christ scale. And then we also asked people about their tendency to worry, how often they worried. And it turned out that there was a minus 0.57 correlation between commitment to Christ and anxiety. As people were more committed to Christ, they worried less. Now, it wasn't a perfect correlation. There's a lot of other factors that influence people's tendency to worry. Some of it's genetic. Some of it has things going on has to do with things going on in your life. One of the best predictors was how close they were to graduation. Seniors spent a lot more time worrying than freshmen did, which is a pretty common phenomena because once you get close to graduation, it's there's a lot of unknowns, and your tendency to worry will go up. Now, another variable measured was the shoe size and year in school. And here we got a real little absolute value. It's close to 0, minus 0.049. And we're going to see later in the course that we're going to say, oh, this is not significant. It's quite possible we got these numbers just by chance, and if we were to do it again, we might get a positive number, because probably there's not really much of a relationship between shoe size and whether you're a freshman, sophomore, junior, or senior. Now, another correlation that was interesting was being from Southern California or not, and the number of shoes that somebody had. So we said if we rated everybody as non-Southern California as 1 and Southern California as 2, the people from Southern California had fewer shoes. It was negatively related to being from Southern California. And I might be wondering, why is that? Well, in Southern California, there's an awful lot of people that just wear flip-flops all year long, and they don't have very many shoes. Whereas people that are from other parts of the country, such as the East Coast or the Midwest, they're not going to wear the same shoes in summer and winter, whereas Californians usually do, or typically do. Then there's another correlation looking at shoe sizes, and there's a positive correlation between the number of shoes one owns and conscientiousness. Now, what's conscientiousness? Conscientiousness is a measure of basically how closely do people follow rules and do what they're supposed to and arrive on time and make sure they do everything exactly the way that they're supposed to. Some people are really into rules and doing things precisely and getting there on time. Other people less so. Other people just see them as guidelines. Well, and so this is an important personality trait, and it's related to the number of shoes that somebody has. The more conscientious somebody is, the more shoes they tended to have. Now, why would that be? That's because conscientious people are going to say, aha, there's a special type of shoe that I should wear on this occasion, and on this occasion I shouldn't wear my flip-flops, but on this occasion I should wear this type of shoe. And so the more conscientious people tend to buy more shoes for the more appropriate situations. Now, how do we actually go about measuring Pearson's R? Well, first, here's the formula that we're going to look at. And remember, we're going to use this. We're going to let Excel do all the calculations for us. But basically, we get for every data point that we have, we measure where it is, the z-score for the x variable and the z-score for the y variable. We multiply them together, we add them up, and then we kind of like take the average, but we use n-1 like we did in the standard deviation. And so variables that go up together, so that they have a high positive z for the first variable and high positive v for the second variable, and the low positive and the negative z's match up too, they're going to have a positive correlation. And those that tend to have a positive z for x and a negative z value for y, they go in opposite directions, will have a negative correlation coefficient. So it's basically a measure of how well the z-scores for the two variables match up. And now, since it's made from z's, it doesn't have any units. We're not measuring correlation in bananas or inches or pounds or anything like that. It's a unitless measure that's independent of whatever measures that we're measuring x and y in. So we can measure the correlation between anything. We can measure the correlation between burritos eaten and height. We can measure the relationship between a personality trait and a person's age. They don't have to be the same things. We can just look to see if any two variables move together.